All right, so we're picking up with the last few questions. Probably get it done in two more parts. We're at question number 5 here. Another kind of analytical thinking question. To answer this one, being that n is going to be some integer, we got to figure out what's going on with these exponents here so we can determine what the degree is going to be and then ultimately how that impacts what the long run behavior will be like. So for this particular question, I'd call you back to an example, maybe something like this. If you had f of x was equal to x squared times x to the fifth, what degree would that be? And how would you know? Well, remember there's an implied 1 right there when it's not written, it's power of 1. So what you do is, since you're multiplying all these leading terms, you're looking at the leading degree for each one, and then you'd be adding the exponents. So this would be the equivalent of having something like x to the 2 plus 1 plus 5, that's like x to the 8th. So this would be an 8th degree function, and then because of that, we'd know that it would be going in the same direction at both ends of the graph. As x goes to plus or minus infinity, this would be going to positive infinity, going up with the leading coefficient being positive. So we can apply that same logic to this one. Even though they're binomial factors, the leading term is going to dominate. It would be x to this power as the leading term, just like x to this power is going to be the leading term of that factor. And then when you have a product of those, you'd be adding those leading term exponents together, just like we did here. So what we get as a result is, if we highlight the two exponents, we have an exponent of that power and an exponent of this power. Similar to what we did over here, you'd be adding those exponents up. So this total degree here would be the power of 2n plus 4n plus 3. So a grand total of 6n plus 3, where n is some integer. So that's the degree of the function. Now, what does that tell us about the behavior? Well, if you think about it, no matter what number n is, as long as it's an integer, 6 times that number is going to be some even number, plus 3. So this is guaranteed to be some odd number, no matter what n you plug in. 6 times 1 is 6, plus 3 is 9. 6 times 2 is 12, plus 3 is 15, and you can keep on doing that forever. No matter what n is, 6n plus 3 has to be an odd number. So what that does is it tells us a couple of things. We know that because it's an odd degree, we know that the function has to be going in opposite directions. Either it will be going up on one side and down on the other, or it will be going up on the opposite side and down on the other. So one of these two cases, it's either this or it's this. And how do we know which one it's going to be? Well, if you remember, the leading coefficient will determine what's happening as you go in the long run behavior. So for a negative leading coefficient, that means it's going to be going down as you go out towards positive infinity in the x direction. So this graph has to do something like this. It's got to be in that shape. There could be a lot of bumps in here, but we know that as you go out to negative infinity in the x direction, it's going to go up. And as you go out to positive infinity in the x direction, it's going to go down. Right? And that's because of the leading coefficient being negative. So as x goes, again, to positive infinity, that means as you go to the right, f of x, as I go to the right, is going to approach negative infinity. It's going to go down. And as I approach negative infinity in the x direction, that means, again, as I go left, then the graph itself, as I go left, it's going to go up. So it's going to go towards positive infinity. All right. Let's see if we can get through this next one. Probably finish this one before the next break. Right? If x minus 2 is a factor, that means we know that x equals 2 is a root. So we know that f of 2 has to come out to be 0. So they're giving us the function here. If I know that f of 2 has to be 0, I can substitute 2 in for x. 2 times 2 cubed minus k times 2 squared plus 2 minus 6. And I know all of that has to be 0 because 2 being a root means the graph has to equal 0, and that comes from knowing the factor of x minus 2 is a factor of this. So now I can work this out. I get 2 times 8 minus 4 times k plus 2 minus 6. All that has to be 0. 16 minus 4k minus 4 has to be 0. 16 minus 4 is 12, minus 4k has to be 0. If I add this over, 12 is equal to 4k. So therefore, k has to be 3. We can finish out